All right, let's go ahead and get started. Our first section is going to be Chapter 7, Section 7.1, and what we're going to be learning about is something called a confidence interval. I already sort of explained this in class on the last day, but it was kind of at the end of class, so we're going to go over it again. A confidence interval is where you take a survey of something, and using a statistical formula, you can build an interval that has a high probability of capturing the value that you want. For example, imagine that you're running for political office, and I say, and I go out and I say, okay, let's find out how popular you are. And imagine that I ask 300 people if you would vote for you for office, yes or no. And then let's say that they came back and 55% of them, of the people I surveyed, said that they would vote for you. That's a positive sign, because you only need 51% to win. And so what that means is I've just given you 55%. However, I can do better than that. I can build a confidence interval that has a high probability of containing the true answer. So maybe my confidence interval says, 53% to 57%. And I say, the best guess I can give you is that 55% of the people in the survey said they would vote for you, but I'm 95% certain that the amount of 53 to 57 captures whatever the true answer is. I'm 95% confident, not that it's between these two numbers per se, but that this confidence interval captured whatever the true number is. So here's the idea. And I know this text is small, I'm sorry. Please print this out yourself so that you can work through this with me, so that you can see what the text is saying. Here they've given us a confidence interval of 0.075 to 0.129, and they want us to put it in the form p hat minus e is less than p is less than p hat plus e. Okay, what is p hat? P hat is the best point estimate. And that's like that 55%. That's the actual answer you get from your, that's the actual number you get from your survey that you send out. That's the best point estimate. And E is the margin of error. And so I'm going to show you in a second how to calculate the margin of error. And so we got our best point estimate and our margin of error. So if we want to write this as a confidence interval, it's actually really easy. We do a survey, and when a confidence interval is written in this form, you can just write it like this. So that's what the answer is they're looking for in this first chapter on 7.1. Pretty easy. It's just that we think our value might be between these two numbers, or rather we have a certain confidence that this interval contains the true answer. So let's actually look at an example, and so I think after we get through this example, you'll understand it. So here's the idea. A drug is used to prevent blood clots in certain patients. In clinical trials, among 4,861 patients treated with the drug, 169 developed nausea. Construct a 90% confidence interval for the proportion of adverse reactions. Okay, here's the idea. We've developed a new drug, but we need to test if it has side effects. We gave the drug to 4,861 patients, and 169 of those developed a side effect. So we're going to construct a confidence interval to see what percentage of people get that side effect, because if a large number do, then we'll have to put that in our advertising that that side effect is common or that you might be able to get it. So let's go through this one step at a time. First, find the best point estimate. All you got to do is just find the percent of people that have the side effect. So all we need to do is say, okay, well, based on our survey, 169 out of 4,861 people developed the side effect. If I grab my calculator, 169 divided by 4,861 is going to be 0.0347 665. Okay, so that's it. So about 3.4% of people are going to get this side effect. Now, the thing asks us on my notes to round, so you have to figure out how you need to round it. I'm going to round it to 3 decimal places. So if I round it to 3 decimal places, I get 0.035. So 3.5% is our best point estimate. That's our p hat, okay? That's our p hat right there. And I might switch to a pen in the next video because I see that's a little hard to see. But 0.035, that's our p hat, that's our proportion. Next, it asks us to find the margin of error for our confidence interval. The margin of error is equal to z alpha over 2 times the square root of p hat q hat divided by n. Okay, let's break this down really quickly. P hat we already know. Q hat is equal to just 1 minus p hat. And n is always our sample size. Okay? So q hat is equal to 1 minus p hat. N is our sample size. So that leaves the question of this number right here. Okay? Z alpha over 2 is kind of like standard deviation. It's sort of similar, is our critical value, and it's kind of like a standard deviation. And now you see this alpha over 2, don't worry about that. Just know that this Z alpha over 2, this whole thing is just one number. This whole thing is just one number, and we get this number from a table. Okay? In fact, we get it from the Z table, but I've made a simplified table for you. So, here's how we're going to do it. For this problem right here, we're going to calculate E. And so let's find the Z alpha over 2. Before we do that, we need to know what our confidence level is. So do you see right here, it says we have a 90% confidence interval? Here's how you do it. Go to the flowchart that I made, and you'll see in the lower left-hand corner, I've made a special table for you called Common Z Critical Values, okay? That's the table we're going to use. And notice at the bottom, I say all confidence intervals are two-tailed tests. That's extremely important. You should maybe underline that. All confidence intervals are two-tailed tests. So remember that. Here's how easy this is. We have a 90% confidence level. So find where it says two-tail, because all confidence intervals are two-tailed. Then come down to 90%. Boom, there's your number. It's hard to read, but it's 1.645. That's it. That's it. 1.645. So this whole Z alpha over 2 scary looking thing, the alpha over 2 is just to remind you that it's a two-tailed test. That's all it's there for. This whole number became 1.645 because all I did was I went to a 90% confidence level. I remember that my confidence interval is two-tail always. So two-tail, 90%, 1.645. That's kind of like standard deviation. It's like 1.645 standard deviations, kind of. So that's it. 1.645 became the Z alpha over 2. Then we times that by the square root of p hat, which was 0.035. Let's figure out what q hat was equal to. I grab my calculator, and we do 1 minus 0.035, and I get 0.965. Okay, so I figured out that q hat was equal to 1 minus 0.035, which was equal to 0.965. And then finally, the bottom number, n, is just our sample size, which is 4861. And that's it. That's all you got to do to find the margin of error. Of course, now we've got to plug this whole thing into our calculator. I don't recommend plugging the whole thing into your calculator all at once because you're more likely to make a mistake that way. So let's do it this way. Let's start inside the square root. So we do 0.035 times 0.965, enter, divided by 4861, enter, and we get a really tiny number. I'm going to need to take the square root of that number now. So on my calculator, I can take the square root by just hitting second and then the square root sign, and then I can just put in the answer. You might do something similar on your calculator. If you're confused, just send me an email. I'll try to work it out with you. And we get this number. So this number is our square root. Now I just times that by 1.645. And I get 0.004. And that is indeed the answer. So the margin of error is 0.004. Okay? It's really important that when you do the square root that all of this goes inside the square root. So that's why I figured out this number first, then I took the square root, then I times it by 1.645, and that's how you should do it. So we're almost done. Now let's construct the confidence interval. And remember, we had the idea of the confidence interval right here. It's p hat minus e is less than p is less than p hat plus e. So p hat minus e less than p hat plus e is our confidence interval. So let's grab p hat, which was our best point estimate. So that's 0.035 minus e, which was 0.004, is less than p, is less than 0.035 plus 0.004. That's it. Okay, so now let's do that in our calculator, 0.035 minus 0.004. So I'm going to get 0.031. Okay, is less than p is less than 0.035 plus 0.004. And I get 0.039. So take a look at that. All right, so that's the answer. Now, the reason I pause is because my answer guide says that the answer should be 0.030. I think it should accept it either 0.030 or 0.031. But what I should have done is taken this 0.004 to more decimal places. So you can never be hurt by taking it to more decimal places, but hopefully it would accept that answer either way. If you keep getting really, really close but not quite correct, try doing more decimal places into your calculations. So instead of doing 0.004, I should have done 0.0043, and maybe that would have made the difference. But I don't know. Hopefully they'll make it correct, even if it's off by a tiny bit. Okay, we're almost done. So let's answer this final question. So here's our confidence interval. 3.5% of people appear to have symptoms. However, we have a confidence interval of 0.031 to 0.039. We are 90% confident that this interval trapped the true value. We're not saying that we're 90% sure that we're between these two numbers. We're saying that we're 90% sure that think of this as like a net, and that the true population parameter as being like a fish, and we're 90% sure that this net caught the fish. We could do another survey, and we would get slightly different numbers here and here, but it would probably be close to the same thing, and we'd be 90% sure that we caught the fish with that net too, that we didn't just get an unlucky sample. So when you look at these 4 questions down here, which I know you can't read, so you need to print them out. When you look at these 4 questions down here, what we're really saying is choice C. So let's look at the incorrect answers. There's a 90% chance that the true value of the population proportion will fall between the lower and the upper bound. That is not correct. That's the equivalent of saying that we're 90% sure it's between these two numbers. That's not what we're saying. We're saying we're 90%, let's read the next one. One has a 90% confidence that the sample proportion is equal to the population proportion. Absolutely not. Number 2 will almost never be true because this is just a sample value. Who knows what the true population proportion is? Nobody knows. That's why we're doing statistics. We're trying to guess at the right answer. 90% of sample proportions will fall between the lower bound and the upper bound. No, that's the opposite of what we're saying. Only 10% should fall. Actually, that's not even true either. So it's definitely not D. The answer is C. We're 90% confident that our interval captured the true population proportion. So that's that. I know this feels a little bit overwhelming, but everything we just went through is actually something that we're going to do repeatedly. It's just that the formula changes a little bit. Now, check out my cheat sheet. What you'll notice is on the first page, it says, I am constructing a confidence interval. And we have a series of questions that we ask. Look at this first question. Is it a proportion? This formula is section 7.1. This is the formula we just did. Notice that it's p minus z alpha over 2 square root of p hat q hat over n less than p hat plus z alpha over 2 square root of p hat q hat over n. Remember, this value right here is e, the margin of error. So it's p hat minus e less than p hat plus e. And notice that p hat is used twice, once in the margin of error and once because it's our best point estimate. So look, in our first video, you've already learned the first formula on this flowchart. Okay, you've already learned it. So that's how you construct your confidence interval. This video is getting a little long, so I'm going to stop it here. Please don't feel overwhelmed. I know this was a big process. If you got confused on any parts, rewatch it or send me an email. But you've gotten your first taste of constructing a confidence interval. I'm going to stop it here, and we'll start the next problem in the next video.